Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to be talking about connecting representations of limits. That's basically going to be our mid-unit review. We're going to review all the different types of limits that we've used before. So let's get started. So there are 4 different ways to describe a limit. There's a verbal way of describing it, just explaining what the limit is. For example, as x approaches 6, f of x approaches 7, or the limit as x approaches 6 of f of x equals 7. And that's how you describe this notation down here. This is limit as x approaches 5 of j of x equals 2. You can write it using algebraic notation. And limits can also be expressed using a graph like this. You have some different limits here, and a value can be undefined and still have a limit that exists. But if the left and right don't match, then the limit doesn't exist. And limits can also be expressed with a table. So if you have Gizmo's flight path from earlier, you have you have t getting really close to 7 and g of t getting really close to 25. And sometimes on the AP test, they'll ask you to connect different representations, like match a table with a graph or match an algebraic notation with the graph. And let's look at a few examples here. So okay, first problem. The graph of g of x is shown below. Describe in words what the limit is at x equals 4. Well, if you follow this graph, you can trace it like this. It looks like we're getting really close to x equals 4, and from both sides, it seems like we're approaching 3. So the way to describe it is the limit as x approaches 4 of g of x is 3. It's getting closer to 3 as we're getting near 4 in the x direction. And sketch a possible graph of Shadow's flight if his y position is approaching 6 near x equals 11, but his y position at x equals 11 is undefined. So this is basically the Shadow realm problem. He's going to be flying along on some path, but there's just going to be one point where he just doesn't exist. And then he's just going to keep going like normal. And I'll let you think about it for a minute yourself. You can pause the video of what a possible graph would look like. There's more than one right answer. You can draw any graph as long as the limit is good. Okay, so here's what it's going to look like. So Shadow, let's have Shadow start down here. And you can do any sort of path before x equals 11. But remember, when we're approaching x equals 11, we want to get his y position right up near 6. So that's going to be like right there. And then it's undefined, so we're going to draw an open circle. And then it can be anything after x equals 11. So it's just going along that path like that. And as long as you have a path with an open circle at 11.6, that would be correct. So now we're going to look at a sort of AP style question that is going to use basically all of the techniques that we've done so far. So the question is, what eagle matches the graph? So we have 4 different scenarios with eagles flying. And we want to know which one of these could possibly be described by this graph right here. Now, you notice that from the left, as x approaches 4, it's 1, and from the right, it's -1. So the limit's not going to exist. So let's try to find one where the limit doesn't exist. So Jackie is flying towards x equals 4 from the left, and Shadow is flying towards x equals 4 from the right. They both approach y equals 5 as their x positions get closer and closer to 4. Now you can see that's obviously not what the graph is there, because their limits match and they're not 1 or -1. So it's not A. Now let's look at B. Jackie is flying with the function square root of x minus 2 times x minus 2 squared, and Shadow is flying with the function x minus 4. Sunny's y position is going to be Jackie's y position divided by Shadow's y position. So that's going to be like Sunny the quotient flyer. And we can hop over to the calculator to see this. So Sunny is going to have a y position that is Jackie's divided by Shadow's. So that's going to be this function right up here. And this is all stuff we've seen before. We know how to do this square root thing. So let's take this x minus 2 squared out of here and put it down here. So we're trying to find the limit as x approaches 4. So it's going to approach 4 minus 2 squared, which is 4. So we're just going to substitute that out for a 4. It can do direct substitution. And also our algebraic properties of limits tell us that we can multiply the limit values together if we're multiplying limits together. So let's look at this square root of x minus 2 over x minus 4. You can do the multiply by the conjugates thing, where we multiply out by a square root of x plus 2 on the top and the bottom. And now we have x minus 4, because those cancel out. And we got x minus 4 on the top, x minus 4 on the bottom. Place it with a 1, and bring the 4 up here, so we have 4 over square root of x plus 2. And as x is getting close to 4, square root of x is getting close to 2, so it's 4 over 2 plus 2, and that's going to be 1. Now, if you're going over to this problem back here, in the graph, it's approaching 1 from one side and -1 from the other side. But in the thing, it's approaching 1 from both sides, so it's not going to be B either. Now let's look at C. Gizmo is flying on the x and y axis, and some of her coordinates are recorded in the table below. So we got this right here. And if you look at it, it looks like it matches this pretty closely. Like it's approaching 1, but then it's still 1 after 4, so we know that can't be it. So let's look at D. Spirit is flying along the x and y axis and suddenly teleports at x equals 4. Her y position is always positive for x is less than 4, and always negative for x is greater than 4. Now, that's what it's going to be. It's going to be Spirit, because we see it's positive up here, negative down here, and that matches Spirit perfectly. So, that's it for today, and I'll see you next time.